Good day, everyone. Today we will talk about surface runoff and how engineers study rainwater movement to prevent flooding and design drainage systems. I will also explain some technical terms in a simple way so everyone can understand them easily. Surface runoff is the flow of excess water over the land surface when the soil can no longer absorb water. So this water moves towards streams, rivers, canals, and drainage systems. And surface runoff is important in hydrology and drainage design because excessive runoff may cause flooding and erosion, as what we have discussed before. In this picture, imagine pouring water on a table. So the water spreads and moves because the table cannot absorb it, just like the picture below. No? So in the same way, when too much rain falls and the ground cannot absorb all the water, it flows over the land surface into canals, rivers, and of course, drainage systems. So peak flow rate means the biggest amount of water flowing at one time during heavy rain. So think of a crowded road during rush hour. Many cars pass at the same time, right? So in drainage systems, engineers need to know the rush hour of water so pipes and canals will not overflow. And to compute for the discharge, we are using the rational method formula for us engineers to use and to estimate how much rainwater will flow in a drainage area. So the formula is Q equals C times I times A. So here, C tells how much rainwater becomes runoff. That's the coefficient. I is how hard the rain falls, meaning it's the intensity. And A is the size of the area. So it is like calculating how much water can fill a bucket depending on the rain and the bucket size. So when we talk about time of concentration, it is the time needed for rainwater from the farthest part of the area to reach the outlet or drainage point. So imagine children running from different parts of the playground toward the gate. So the last child to arrive represents the farthest water flow. So when all the water arrives together, the runoff becomes the greatest. Then we also have here runoff volume. So it is the total amount of rainwater flowing over the land after rainfall. So think of filling a pail of water. So the more rain falls, the more water collects and flows away. So some water goes into the soil, but the raining water becomes runoff. So the formula is runoff volume is equal to the area multiplied by the depth and the rainfall coefficient. For the unit hydrograph, peak discharge, it is the highest water flow produced by a standard amount of rainfall. To explain simply, imagine pouring 1 cup of water into a slide and observing the fastest flow at the bottom of the slide. Engineers use this idea to predict floods and water movement in watersheds. On the other hand, we have runoff ratio. It tells us how much rainwater become surface runoff. So for example, if half of the rainwater flows on the surface and the other half goes into the soil, the runoff ratio is 50%. Roads and concrete areas usually have high runoff ratios because water cannot easily enter or penetrate through this pavement or um, concrete pavement. So the formula is runoff ratio is equal to the total runoff recorded over the volume of 1 inch direct runoff. Now let us solve some engineering problems to see how these concepts are used in real drainage and highway projects. Okay, so let's have problem number one. A drainage line of 1.4 kilometers is designed based on the storm on 6 hectare property, which produced 40 millimeters per hour, assuming the velocity flow of zero point 0.8 meters per second. and the runoff coefficient is zero point 0.5, what is the time of concentration in minutes and the peak discharge in cubic meters per hour, which can be expressed from the area? So in this problem, we are given the drainage line length, the rainfall intensity, the runoff coefficient, and flow velocity. So we will calculate the time of concentration and the peak discharge from the drainage area. So these are the given values needed for the solution. We have length of drainage line, that's 1.4 kilometers. Area, we have 6 hectares. The rainfall intensity I is 40 millimeters per hour, and the runoff coefficient is zero point 0.5. Also, we have velocity V, zero point 0.8 meters per second. Then we are asked to determine the two things, the time of concentration and the peak discharge. So these values help us engineers know how fast and how much water will flow during rainfall. To solve for the time of concentration, we divide the distance by the velocity. So it is similar to finding how long it takes to travel somewhere by using distance and speed. Diba? So easy. After substituting the values, we simplify the equation and convert the answer into minutes. So we get the result of time of concentration equals to 29.17 minutes. So please check the solution. Okay, so thank you. So moving on, we solve for the peak discharge using the rational method formula. But before solving, first convert all measurements into compatible units for consistency. So we have 40 millimeters per hour. So we have to multiply it by 1 meter per 1000 millimeters. That's 0.04 meters per hour or meter per hour. Please check. And we also have 6 hectares. Multiplied it by 10,000 square meters per hectare. So we have 60,000 square meters. Please check the solution. Of course, unit conversion is important because all values must match correctly. So it is like making sure all ingredients in recipe use the same measuring system, diba? So using the formula, we can also solve for Q or the peak discharge. We have 0.05 multiplied by 0.04 multiplied it by 60,000. What is the value of peak discharge? Please check our solution. So after substituting the values into the formula, we obtain the peak discharge of 1,200 cubic meters per hour. So this tells us the maximum amount of runoff water expected during the storm. Okay, so any questions with problem number one? Okay, so moving on, we have problem number two. On a certain highway project, see the diagram on the right side. The design of pipe culverts will be based on a storm which produced 50 millimeters of water per hour, assuming the velocity of flow is zero point 0.9 meters per second. The runoff coefficient is zero point 0.5. So we will use rational method for runoff computation. So use pipe slope S of 0.0023 and roughness coefficient N of 0.013. Then determine the longest time of concentration, T sub C in minutes. Determine the peak discharge from the area and determine the size of two concrete pipes. So we're given the formula for Q, no? And also the hydraulic radius R. So in this problem, we design pipe culverts for highway project. When we say culverts, these are pipes that allow water to pass under roads to prevent flooding. So this slide shows the given values such as rainfall intensity I equals 50 millimeters per hour, the runoff coefficient C 0.5, velocity V 0.9 meter per second, Pipe slope S is equal to 0.023 and the roughness coefficient of 0.013 uh, needed for our computations. To find the longest distance, we use the Pythagorean theorem. Remember this formula? Ano nga yan, Gids? Mm-hmm. Tama ba yun? So in a right triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. Tama? Okay, sige. Let's move on. Please compute the longest flow distance. D is equals to square root of 1,350 raised to the second power plus 335 raised to the second power. D is equal to, okay, flow distance is equal to 1,390.94 meters. Okay, please check. Sige. So once we know the longest distance, we divide it by the velocity to determine how long the water travels. So that is time of concentration, T sub C. No? That's equal to D, which is 1,390.94 meters over zero point 0.9 meter per second. Multiplied it to 60 seconds per minute. Okay, then let's calculate T sub C. And the answer is T sub C is equal to 25.76 minutes. So it means that it takes about 25.76 minutes for rainwater from the farthest point of the drainage area or watershed to reach the outlet or the drainage point, which is the culvert. Next, we calculate the peak discharge using the rational method. These help us engineers know the maximum flow that the culverts must carry safely. But before that, we simplify or convert rainfall intensity of 50 millimeters per hour to meters per hour. So multiply it by 1 meter per 1,000 millimeters. We have, okay, we have 0.05 meter per hour. Please check the solution. Then compute the drainage area. That's 670 meters. Multiply it by the length 1,350 meters. So the answer is, so the area is 904,500 square meters. Okay, let's move on. Next, we calculate the peak discharge using the rational method. So this helps us know the maximum flow rate the culverts must carry safely. So Q is equal to C, which is zero point 0.5, I 0.05, and multiplied by A or area 904,500. Okay, let's compute. Pila ang peak discharge last? Okay. The result for peak discharge Q is equal to 22,612.5 cubic meters per hour. So a flow rate of this amount, no, means that every hour about 22.6 million liters of water are flowing through the drainage system. Then convert the discharge into cubic meters per second. So Q, which is equal to 22,612.5 divided by 3,600 seconds. So we get 6.28 cubic meters per second. For calculating the total discharge, we divide the value between the two concrete pipes since both pipes will carry the runoff water together. So we have 6.28 cubic meters per second divided by 2. The result is the discharge per pipe is 3.14 cubic meters per second. Any questions? Clarifications? Okay, so let's have the activity. Okay, so I will give you 20 minutes for this activity. Okay, thank you so much, guys, and see you next week. Maraming salamat.